All right, guys, so today's lesson is called converting rates, okay? Converting unit rates, that is, to be more specific. So it's just changing unit rates, all right? And we're gonna talk about what it means to change unit rates. But there are some vocab that is involved. So here we go. Our very first vocabulary word is unit ratio. Everyone?
Unit ratio.
All right, so here's what the book says a unit ratio is. It's a unit rate where the denominator is 1 unit. A unit rate where the denominator is 1 unit. Now you might say, okay, Mr. Wilkins, unit rate, denominator 1, I understand. Okay, well this one, the unit ratio is a little different than a regular unit rate. Okay, so here's your example. I'm going to go ahead and write it down right up here. Go ahead and put down 12 inches over 1 foot. Just like that in your little box. 12 inches over 1 foot. Inches over 1 foot. Now, you might say, okay, Mr. Wilkins, that's a regular unit rate. It's like 12 inches per foot. Okay, I understand. I mean, that's what we're doing, like 65 miles per hour. It's just like everything we've done. Okay, well, this one is a little different. Take a look at the top. Take it all in, all right? The whole number and units, everything. Take the meaning of the top, and then take a look at the meaning of the bottom. This is a little different. All right? Who can tell me what do you see? Nico?
They're equal?
They are equal. If you don't believe me or believe Nico, ladies and gentlemen, how long is that? 12 inches, but I also just heard someone say it's 1 foot, and both of you guys are right. All right? 12 inches is 1 foot. So, ladies and gentlemen, the top and the bottom are exactly the same. Now, let's talk about some stuff that we know about when the top number and the bottom number of something in fraction form, when we know it's the same. For example, what's 5 over 5, ladies and gentlemen? What is it simplified to?
1.
Yeah, 1, right? In elementary school, we learned that when it comes to fractions, if you have the same number on top and bottom, we get it simplified to 1 whole. Okay? What about, let me make it really hard. 162 over 162.
1.
Yeah, 1. All right? Happy face over happy face. What is it?
1.
It's 1. Wait, what? What blows your mind, right? But guys, ladies and gentlemen, the definition is if the top and the number on the bottom are exactly the same, it's 1. If it's the top and bottom are the same, it's 1. If the top and bottom are the same, it's 1. So I know these look different, but realistically, this is equal to 1. Now let me ask you guys another elementary school kind of idea. What happens when we multiply by 1? 5 times 1 is?
5.
162 times 1 is?
162.
Happy face times 1 is? Okay. Anything times 1 is itself. Anything times 1. Anything times 1 is itself. Okay? So 2 basic things that you should know, that anything when it shows on the top and bottom are the same, it's 1. And of course, anytime we multiply by 1, you're going to get the same thing. Okay? I want you to keep those 2 ideas because we're going to talk about those in our lesson. Okay? Now I also want to just point this out too. Just keep in mind, 1/2 can be written 2 different other ways right off the top of our head, right? It could be written as a decimal. It could be written as a percent. These all look different, but they're all the same. So in math, there's things that can look different, but they're the same. For example, 12 inches and 1 foot. They look different, but the value is the same. 2 1/2 is the same as 5/2, right? They look different, but the value is the same. So these two values are the same, even though they look different. Okay? If they're the same on top and bottom, it's 1, and anything times 1 is itself. Okay? Any questions about those three ideas? I should not have shown you anything that just blew your mind. This is all elementary school stuff. I just wanted to make sure I reminded you, because we're going to be talking about these things when it comes to today's lesson. We're okay? Okay, here we go. Our next word, that was a little reminder of what I just told you. Now, today we're going to be converting rates using a certain strategy. Okay? That strategy is called dimensional analysis. Everyone? Dimensional analysis. All right, so here's what dimensional analysis. Your book says it's the process of including units of measure when you compute. The process of including units of measure or units of measurement when you compute. So, go ahead and write this down. 2 feet per second, or 2 feet over 1 second, times 12 inches over 1 foot. Okay? Now, listen. That probably doesn't make any sense to you, but that will make sense to you hopefully after this lesson's over. So when you look back into your vocab, you'll look at this and say, oh, that's right. That's what dimensional analysis means. Okay? All right, now, there is one other skill I want to talk about. This is an elementary skill, but we've actually had a lesson on it this year. Okay? Let's talk about something like this. Multiplying fractions. Now remember, when we multiply fractions, first of all, we can multiply straight across, right? It's just multiplication. We can multiply straight across, and then if we need to, we can reduce at the end. But I also taught you a different method, all right? We can reduce before we multiply. How can we do that? Okay? We can, what we called cross-reduce. Right? 3 and 3, we can divide both by 3. 3 divided by 3 gives us 1. 3 divided by 3 gives us 1. We can reduce diagonally, which is called cross-reducing, when it's multiplication. Okay? Now, going back to what Jaden said, what will happen is many times when you are reducing the same number, some people call it actually cross-canceling. And the reason why it's called cross-canceling is because when they become ones, what ultimately happens is 2 times 1 is 2, 1 times 5 is 5. It's almost as if you just canceled out those two numbers when they're the same. And you end up with what's left over in your numerator and denominator spot. So we talked about cross-reducing, but when you're reducing the same number diagonally, they basically cancel each other out. That's what ultimately is happening. So some people call it cross-canceling. Okay? Now, before I move on, we need to understand all of that. Any questions on cross-canceling? So when it's multiplication, and when you're dealing with fractions or ratios, and you have the same number or the same thing diagonal from each other, we can cross-cancel. So what I mean by that is this. 2 over 162 times 162 over 5. Oh, it's huge. Well, not if you cross-cancel. It's 2/5. all we're doing is dividing both of them by 162, which they become 1s. And again, 2 times 1 is 2, 1 times 5 is 5. So we're just cross-canceling. What about this? There's happy face again. What can we cross-cancel, guys? Happy faces. And we end up with 2 fists. See that? Any questions on cross-canceling? Okay, here we go. I really want to look at happy face because I know that's kind of silly. It gives you the idea, though, that there could be anything top and bottom like that diagonally, and cross-canceling works on it. Okay? Because we're about to see something similar to that. All right, here we go. What if we have gallons over seconds times seconds over minutes? What can we cross-cancel? Seconds. What's left? Gallons on top, minutes on the bottom. A little bit of basic dimensional analysis, or an example of what we're going to be seeing. What about this one? We have, hours over feet times minutes over hours. What can we cross-cancel? Hours, right? We can cross-cancel this way. What do we have on the top? Minutes. What do we have on the bottom? You can actually cross-cancel units. All right? This last one we're going to talk about in our lesson. Okay? Any questions about stuff that I've talked about so far? Okay, we're going to keep building on this. So here's what I'm going to do. I'm going to give you guys a quick 1-minute breather, but as soon as this buzzer goes off, we're right back to it for our examples. Okay? So 1 minute. Okay, go. All right, guys, start making your way back to your seat, please. All right, here we go. So, for examples, for some of our math problems, before we even get to it, here's what I want you to do. I want you to turn in your book to page 26. Ooh, a couple of you guys are already there. Awesome, awesome. Okay. Thank you guys for being ready. Now, you see the two little charts, the two little tables up at the top there that are like the headings are in green, right? Now, remember what we did. We talked about unit ratios, and the unit ratio, right, the specific unit ratio we talked about was 12 inches over 1 foot, right? How the top and bottom are the same, they just look different, okay? The unit ratio is going to be a huge part of our lesson. All right? It has a meaning of 1, but it allows us mathematically to do some things using dimensional analysis. those two tables on the top of 26 are going to be like your best friend during this lesson. Okay, remember whenever I said, guys, when we're getting deeper into this year, I'm letting you use calculators. And that's because I don't want you having to worry about the big multiplication and big division. That's not the objective. The objective is to be able to, set up proportions and know how to deal with ratios and unit rates and everything like that, right? So I let you use the calculators. Well, during this lesson, is going to be the calculator, because I don't want you to have to worry about conversion rates. These are all a list of the conversion rates in those little charts there. Okay? So whenever you're going to see a part that will say, okay, find out the unit ratio to use and write it down. Well, when we do that, if you don't know what the unit ratio is, you're going to flip to this page and look. Okay? This is a big helper. Now, what else I want you to write? Two things that you're going to need on your homework tonight that are not on that chart, I want you to write down. Go ahead and on the left side, right, there's that little indentation there that is for notes. I want you to write these two. 3,600 seconds equals 1 hour. 3,600 seconds equals 1 hour. And 1,760 yards equals 1 mile. Those are two that you need to make sure that you have down there. Okay, I'd really write them up by the rest of them, because you might not, if you write them down below or hide them in the different words, you're going to lose them and not know where they are. I'd really write them on the side or right below the charts, the tables. Now here's what else I want you to do just really quickly. Flip to the very back of your book, back cover. Okay, inside the back cover. If you take a look at that bottom section, there's some more there too. Okay, so it's just an extra resource for you to use, okay, when you are dealing with unit ratios. Okay, so just be aware of those two places to find them to make your life a lot easier during this lesson, where you don't have to worry about those things. Okay, bless you. Okay, let's get going on our lesson. So let's go ahead, flip over to page 28. Page 28. All right, let's go ahead and read on page 28. Let's read number 2. Let's close read that. It says, a skydiver is at about 176 feet per second. How many feet per minute is he falling? Okay. Now, I'm going to walk you through this. Here we go. Step 1. Okay. Step 1 is we are going, and I'm going to write more notes than usual out in words. All right, so you need to make sure you write these down as a helper. We're going to write down our given rate. In this case, our given unit rate. So they start off right at the very beginning. And remember, in past lessons, I wanted you to write the final answer using the word per. Well, this is one of those reasons, because you should be able to have an easier time identifying it. It says a skydiver is falling at about 176 feet per second. I'm going to go ahead and write that unit rate. That's what unit rate they give us, 176 feet per second. So I'm, however, going to write it in fraction form. So 176 feet over, and then remember per is 1, so 1 second. Now, step 2. Step 2 is the most important step of this lesson. And it's the step that students usually find the hardest, because this is the meat of the lesson. This is where everything is brand new. Writing down a unit rate that's given isn't that hard. Step 2, though, is the main part of the lesson, so listen carefully. First, and a lot of people love mental math, but then when I put a mental math question as notes, they don't want to do it. So please do this. Step 2 is you need to ask yourself, What's changing? What is changing? So write that note down and I'll be more specific. What's changing? So, take a look. They tell us the skydiver's falling at 176 feet per second. Let me say that again. You said like how I got it louder. Feet per second. Look what the question asks. How many feet per minute is he falling? What just changed between what was given in units and what they're asking for? What just changed? See? Seconds and minutes. I'm going to put right down here for note purposes. Seconds and minutes are not the answer to all our problems. It's just to this one. But the seconds are turning into minutes. So, here we go. Let's find the unit ratio that has seconds and minutes. Now listen, if you don't want to think, you can look on page 26, you can look in the back of the book, but I think a majority of you guys will know this, guys. What would be the unit ratio of seconds and minutes? 60 seconds and 1 minute. They're the same, right? So here's what we're going to do. We're going to multiply by that. So, 60 seconds and 1 minute. Now here's one last thing for step 2. We need to remember the whole purpose of step 2 is we're going to do some cross-canceling, dimensional analysis. So listen, 60 seconds and 1 minute. I'm going to write down 1 minute and 60 seconds. There's our unit ratio. However, there's a problem. Can I cross-cancel this? Seconds and feet, minutes and seconds? Can't cross-cancel that. You don't cross-cancel side to side, right? That's the whole reason why it's called cross-cancel. It's diagonal from each other. Listen, do not be scared on your lesson, on your homework tonight, to erase and switch them when you notice that you made a mistake. That's okay. Switch them. Either way, the top is the same as the bottom. Okay, now I want to review this real quickly. You know why we're doing this? Ladies and gentlemen, we're taking this, we're multiplying by that. But what is that? We talked about it during vocabulary. We're multiplying by 1. And that means when we multiply this by this, all we're doing is we're making it look different. We're not changing the value. That's the neat thing about doing dimensional analysis. So we're using a unit ratio to cross-cancel, okay? And all we're ultimately doing is we're multiplying by 1 to make it look different. So here we go. By the way, little side note, we're adding fractions, and you say, oh, I have a denominator of 4. What do? We multiply both top and bottom, and we say, oh, 2/4. Well, ladies and gentlemen, we just made 1/2 look different. That and that, if you remember when we did our number line earlier this year, those are the same thing. Okay? That's kind of what we're doing here. We're just making it look different. All right, here we go. Step 3 is actually do the cross-canceling. Actually cross-cancel. So we can cross-cancel. If you can cross-cancel numbers, feel free. Okay, but we're cross-canceling. What are we cross-canceling here? Seconds. So what's left on the top when it comes to units? Feet. What's left on the bottom? Minutes. And now, step 4, we're going to go ahead, we'll just use the verb compute, which means just let's multiply the numbers. So we have 1 times 1, which is 1, and calculator time, right? 176 times 60 is 176 times 60 is 10560, which is 10,560. Now comes step 5, and that is, let's write it in final answer form, sentence form, and that is 10,560 feet per minute. And if you read the question, it says, how many feet per minute is he falling? And there it is, 10,560 feet per minute. Okay, listen, just a quick overview without going into detail. Here's what you're doing. You're writing the unit rate. You find a unit ratio and that you can cross cancel with, and then you just multiply, and you're going to have your answer. Now, of course, it's not that easy because you have to make sure you're doing all these little things, right? But that is the overall general idea of what we're doing to be able to get our answer. Okay? Here's a popular question. Mr. Wilkins, listen, Mr. Wilkins, come on, can't I just, don't have to do all that, I'll just multiply. Now, ladies and gentlemen, this is the easiest problem we're going to be doing today. It's going to get harder. And it's not always going to be about multiplication or division. So please, show your work, because that's what's going to get you prepared for the next couple of different type of problems we're going to do. Okay? So don't look for an easy way out right now, because you are using an easy problem or easier problem to show dimensional analysis and get good at it. Okay, questions? I'm going to have you guys try one. Okay, they are pretty time consuming. Okay, so here we go. I'm going to give you guys 2 minutes. I want you guys to go ahead and go to page 29, do problem number 3. Problem 3, go. Okay, how many of you need more time? Okay, checking with you guys in about 1 more minute. Okay, checking in. How many of you still need more time? All right, you've got another 30 seconds there. Those of you that are done, you could try other problems. If you get stuck because it's something that wasn't in this problem, that's okay. All right, just stop where you are and then try out another problem because they all kind of look the same, but there are some differences in them. So you can go ahead and start doing a few other problems on your homework. Okay, anyone still need more time? Okay, all right, so listen carefully, all right? You're gonna, of course, I'm gonna give you guys, this first one, I'm gonna give you a full minute to share. The reason is because I want you to start with your final answer, okay? But then I really want you guys to show each other your dimensional analysis part of the problem. I want you to see each other's work. Okay, so do this, and then I want you to talk about this and see if they match. All right, so 1 minute, go. Make sure you're included if it's with them, and you can go over there, over here. Okay, make sure you're talking and visiting. Ellie, I'm speaking to you. All right, don't go right back to your work. I want you to talk to someone about it. Okay. Make sure you raise your hand from now on then if you're not finished. Okay, just looking for answers right now. All right. So let's see. C35, not in this class. C34. Okay, sorry. Say it one more time, loud. Meters per. What is it? Per hour. All right. Agree, disagree. What do you guys think? Okay. A lot of agreements, some disagreements. I'm assuming people that don't have thumbs up or down, which you guys should, is disagreeing. Okay. Any others that people want to share? Any answers? Okay. Let's go to take a look at this. So here we go. So, page 29, let's see. Okay, so page 29 says, peregrine falcon. I am a math teacher, not a bird person, so I don't know if that's how you pronounce that, but I'm assuming. All right, a falcon can fly 322 kilometers per hour. How many meters per hour can the falcon fly? So remember our first unit rate we write down. I'm just going through the steps. So, what they give us is 322 kilometers per hour, so over 1 hour. Then I'm going to go ahead and I ask myself, because that's what this is, what's changing between what's given and what they're asking? Well, it starts with kilometers per hour. They're asking us meters per hour. So I need to convert kilometers and meters. If some of us that might forget that, just write it down. Okay, kilometers and meters. Well, guys, who can tell me when you looked on page 26 in the back of the book, how many meters equal a kilometer? 1,000 meters, okay, equal a kilometer. So here we go. Multiply 1,000 meters over 1 kilometer. And, oh, that's nice because, look, I can cross-cancel. I don't have to erase or anything else. So that's what I'm going to do. I'm going to go ahead and cross-cancel here. I am then going to go ahead and compute. So the bottom is left with an hour, and the top is left with meters. I multiply 1 times 1 is 1. 322 times 1,000 is 322,000. And then, of course, there is our sentence. So well done, most of you guys. Okay. All right, questions. There were a lot of people that either disagreed, or Akash, or didn't quite vote, which tells me it's a disagreement. So if you did not find what you did wrong or know how to fix it, make sure you ask now. Okay, because like I said, these kind of problems are the easiest ones. They're going to get a little more challenging here. Any questions? All right. Okay. Okay, here we go. The second problem is one that I made up because I want you to try a whole different one on your homework, but I made this kind of look like the one on your homework. All right. So here's what you're going to do is just go back. Let's go back to page 28. Okay. You could just do this underneath problem 4. You see how there's some lines there? You can just show your work down there. If you want to cross out 4, put a big X through it, that's fine. All right, here we go. What you're about to see this is going to look just like this, but there's a little twist to it at the end that I want to introduce to you. Okay, that some of these problems this will happen. Okay, so here we go. It says Marvin walks at a speed of 7 feet per hour. How many feet per second is this? Okay, it sounds just like the other one. So I'm going to go ahead, write down my first unit rate, 7 feet per hour. So what is given is 7 feet per hour. And I say, well, what, of course, is changing? So what's changing? Feet per second. Hours is changing to seconds. Hour, just to make a little note to myself, hours are changing to seconds. Now, if you look on page 26, right? How many seconds are in an hour, guys? Some of us are going to guess, and that's where we're going to get ourselves in trouble. Use page 26, please. Use the extra 3,600, 3,600. Okay? That is a perfect example. Some people are just flying out with some guesses. Please do not guess on this. You're going to get the wrong answer. I showed you. Take the time, flip one page over, and take a look. Okay? Please care about your answer to take the extra 5 seconds max to try to get it right. All right? So here we go. It's 3,600 seconds, okay, for 1 hour. So now some of us might get good enough at this where we can think ahead. I'm going to cross cancel the hour, so I'm going to put my 1 hour on top and the 3,600 seconds on the bottom. Now, if you're not good with thinking ahead and you write it down and go to cross cancel, like I said, then erase it and flip it, and that's okay. So I just thought ahead. Here we go. I can cross cancel the hours. When I multiply it out, well, before I multiply, I have feet on the top and seconds on the bottom. And I multiply my numbers. So compute 7 times 1 is 7. 1 times 3,600 is 3,600. Here is step star. Thank you, those of you that are writing this down. We talked about that. We should have our pencils in our hands right now writing it down. This is an issue. Usually we will have the answer. Here's the problem with this. How many feet per second, meaning 1 second? This doesn't come out, some of them won't come out with a nice, pretty unit rate at the end. We now have to use our unit rate skills to find out the unit rate. It is per second, which means for 1 second. So I'm going to go ahead. I put feet over seconds, but remember it's 1 second. So now this is just step star. Change it to a unit rate. In this particular problem, I need to divide both top and bottom by 3,600. And of course, yes, this is a definite calculator problem. 3,600 divided by 3,600 is 1, of course, but we have 7 divided by 3,600 equals, it's an ugly number. Okay, I'm going to go ahead and write it down. It is 0. With 2 zeros, 194 with bar notation. Bless you. Now, I don't know if any of your answers on your homework is going to be this ugly, but you will have some that have a decimal. It's kind of like homework last night. Okay, when you make that unit rate, the top could be a decimal. So I then go ahead and then just finish it off by writing our sentence like the rest of them. Once we have our answer, we have 0.00194, bar notation, feet per second. Okay. Now, just thinking of number sense, let's go back. Marvin walks at a speed of 7 feet per hour. Ladies and gentlemen, 7 feet is from me to, let's say, that table right there. It took Marvin an hour to go from me to that table. More than likely, Marvin is like a pet snail or something. Okay? So if they want to know how far does it travel per second, well, that's why this is such a small little number. I mean, Marvin travels this far in 1 second. Okay, that's how big that is. Remember, that's in feet. So here's 1 foot. It's that much of a foot, which is tiny, tiny foot, part of a foot per second. Okay, that's why it looks so small. Okay, if he only travels from here to there in an hour, you know, every little second, you know, snap of a finger, 1 second, he's not traveling very far. Okay, so very realistic answer. All right. So guys, same as this as it is up here, but some of these are going to need to be reduced at the very end to a unit rate if it doesn't come out as a unit rate. Okay? Any questions before I have you try one like this? All right, here we go. Try out on your homework, page 29, problem number 2. Problem number 2. All right? Check in with you guys in 2 minutes. Go. Okay, who needs more time? Okay, check in with you guys about 1 more minute. All right, anyone need more time? Okay, just about 20 more seconds, 20, 30 more seconds, and then we're going to share. Okay, guys, I'm going to give you guys your time to share. Please listen, all right? There are some people absent. There's been some movement in seats, and please make sure everyone is given an opportunity to share. So if someone is sitting around you, all right, and they don't have their partner's not here, then please include them in your group, okay? Because we need to make sure everyone has an opportunity to share during this time, okay? That way you guys can also help each other out as well, all right? All right, so the same kind of thing, okay? I'm only going to give you guys 30 seconds this time, though. Share your answer. If your answers don't match, then make sure you guys look here, or even the reducing part as well is another place to look. So those two parts will help you guys find out maybe what happened, okay? 30 seconds. Turn to your neighbor and share. Go.
I didn't get anything. I mean, I did, but I don't think it's right. It said 27 minutes. The human brand. Yeah, I didn't see anything there. Because I multiplied 27 times 1 makes 27.
Okay. Number 2. So, taking a look, it says the fastest a human has ever run is 27 miles per hour. How many miles per minute did the human run? All right, so the rate they give us, or the unit rate, is 27 miles per hour. So it's 27 miles over 1 hour. Now, they are changing. It says miles per hour to miles per minute. They're changing hours to minutes. And I know that one. That's 60 minutes in an hour. So I'm going to go ahead and put, I was going to put 60 minutes over 1 hour, but that'd put the hours next to each other. So I'm going to go ahead and put 60 minutes on the bottom, 1 hour on the top. Okay. So when I do that, I can go ahead now and cross-cancel my hours. So I ask, well, what's left on top? Miles. What's left on the bottom? Minutes. And then I have 27 times 1. I compute, so it's 27. And 1 times 60 is 60. So they go 27 miles in 60 minutes. So then, I need to now put down, just miles. Miles over minutes. And they want to know, of course, in 1 minute, right? That's what it's asking. How many miles per minute? So that's 1 minute. So I'm going to go ahead and, of course, divide bottom and top by 60. So 27 divided by 60 is my calculator problem. 27 divided by 60 equals 0.45. So when I write it as a final answer, it is 45 hundredths miles, it's almost a half a mile, per minute. Okay. Questions?
Is there a way to check your answer on these kind of questions?
Probably the best way to check your answer is just kind of ask yourself, like, realistically, okay, does that make sense? Now, some people go, well, Mr. Wilkins, how? I mean, I've ran a mile out there. It doesn't. They ran a half a mile in 1 minute. Well, you have to remember, this isn't a long distance running pace. This is a sprinter. Okay, so that's the fastest, the sprinter. So I mean, it's a short period of time. They couldn't sprint a whole mile, right? I mean, so that's why that's so. But that would be the rate, and that would be pretty realistic because it's a sprinter we're talking about. That would be the best way to check your work, is just, you know, you could check your calculations with the calculator, the numbers, but see if your answer makes sense. Is it realistic? Okay, guys. Any questions on that? All right, that is the end of the first part of converting unit rates.